Good morning, guys. You're able to hear me? So in the last session, we're talking about some word here, discussed some features. Do you remember what all words we discussed? We said Java language is a simple language. We discussed about Java is called as secure language. Java is called as portable language. Java is called as object-oriented language. And we discussed about some word called as platform independent language. This word you can also call it as what? Platform independent, machine independent, architecture neutral. What is the meaning of these words, dear? You can write a Java program in one machine and execute the program on any machine in the world. When you are writing a Java program, the extension of the Java program will be demo.java. Demo.java will contain Java language instructions. These Java language instructions are high-level instructions which cannot be understood by your processor. So what we do is, we give this particular program to the compiler. Am I clear here? What will compiler do? The compiler will take the Java program, read the instructions, verify whether they are valid or not. If they are valid, the compiler is going to generate one file called as .class file. What is the input to the compiler? .java file. What is the output of the compiler? .class file. What will the .class file contain? The .class file will contain something called as special Java language instructions. You can call them as special Java instructions, or you call them as what? Bytecode instructions. What is the meaning of this bytecode instructions? Why we call them as bytecode? Because every instruction in your .class file takes 1 byte of memory. Every instruction in your .class file takes 1 byte of memory. That is the reason they called as bytecode instructions. I prefer to use the first word, special Java language instructions here. I repeat the entire story. Please listen carefully. Demo.java is a program developed in Java language. It contains Java language instructions which cannot be understood by the processor. Why processor only? Processor is the only one fellow who can do the execution, so they have to understand. So processor does not understand this Java language instructions. So what we do is, we give the Java program to the compiler. The compiler will take the Java program, read the instructions, verify whether they are valid or not. If they are valid, the compiler will generate .class file, which will contain special Java language instructions. Now this special Java language instructions available in your .class file cannot be understood by the processor, cannot be understood by the programmer. The only one fellow who can understand your .class file is Jvm. So what will Jvm do? The Jvm will take the .class file, read the special Java language instructions, and then convert them to machine code. Even though your Jvm will convert them to machine code, it is not going to generate separate .exe file. In C language, we can see a .exe file being generated, but in Java language, there is no .exe file generated. Am I clear here? It will just convert and give to the processor for execution. Separate file will not be created there. So this step is called as compilation step. This step is called execution step. 2 steps. First step is called compilation. Second step is called execution. Compilation is done by compiler. Execution is done by Jvm. Compiler will convert Java language instructions into special Java language instructions, and Jvm will convert special Java language instructions to machine instructions. Then it is given to the processor for execution. Now, compiler will convert Java language instructions into special Java language instructions. That is fine. Now, Jvm is converting what? Special Java language instructions into machine instructions. Now, that conversion is done by an interpreter available in your Jvm. Am I clear here? Inside this JVM, there is an interpreter. Execution is done by JVM, but inside the JVM, who is there? Interpreter is available. That interpreter only will convert your special Java language instructions into machine instructions. And that is the reason people say Java is an interpreted language because execution is done by an interpreter available in the JVM. Is the point clear here? The execution is done by the interpreter available in the JVM. So people call Java language as what here? Interpreted language. But yesterday we learned some differences between interpreter and compiler. Do you know the difference between interpreter and compiler? Do you know the difference between interpreter and compiler? Two differences we discussed there. Interpreter does not have memory, compiler has memory. Interpreter is slower, compiler is faster. Now, who is doing the execution here? Who is doing the execution here? Interpreter. But interpreter is fast or slow? Slow. That means execution is only slow. And this is a problem in Java language, drawback. In the not now dear, in the first version, Java released, everyone started using Java language. And everyone had an issue. Everyone telling what? Java is good, features are good, concept is good, programming is good, that is good, this is good. Everyone has a good review. But at the end they say, but execution is slow. Why execution is slow? It is done by the interpreter. So execution is slow. So what did this fellow do now? Along with this interpreter, they added one special compiler called JIT compiler. Inside the JVM, already we have interpreter. Along with the interpreter, they added one special compiler called JIT compiler. Now inside your JVM, two fellows are there. Not one fellow there, two fellows are there. One is interpreter, the other one is JIT compiler. Both will do the execution together. Both will do the execution together parallelly. So if one fellow is doing execution, it is slow. Two fellows are doing the execution parallelly. Then what will happen? Automatically, the execution time will be reduced. Performance will be improved. So people call Java language as high performance language. Java is a high performance language. Am I clear here? Now, you should understand the point. Now, when we have interpreter is slow. Interpreter is slow. So we are taking the help of compiler. Why don't you replace interpreter with compiler? Remove the interpreter and put compiler. Over, no problem. Story. Story is over. But they did not do replacement. There are some reasons that we are going to learn that also now. Why they did not replace the interpreter with compiler? Why they added extra compiler? These all points we are going to learn now. So inside JVM, we have interpreter and JIT compiler, which are going to execute the code parallelly, reducing the execution time and improving the performance of the application there. How it will improve, what it will improve, everything we will go and discuss here. Am I clear here? Then I'll put one more word here. I call it as Java is a dynamic language. C is a static language. C is a static language. Java is a dynamic language. What do we mean by C is static and Java is dynamic? In C language also you compile the program and you do execution of the program. Java also we compile the program and we do the execution of the program. Now what happens is, here in C language, when you are compiling the program, during the compilation time only, it is going to execute during the compilation time only, it is going to what? Allocate memory in C language. In C language, allocation of memory happens during the compilation time. Now what happens? If you are allocating memory at compilation time, I may not do the execution of the program. I only compile and leave it. I don't want to do the execution. Then what will happen? The memory which is allocated will be wasted. The memory which is allocated will be wasted. And whenever they allocate memory, the allocation of memory is fixed. They give some amount of memory. You use it or not is your choice. Memory is going to be wasted like that. If you use it, very good. If you don't use it, memory is going to be wasted. That is a problem in C language. So what they've done in Java, in Java language, there is no allocation of memory during the compilation time. The allocation of memory happens during the execution time, and allocation will be done by your JVM. Dynamic allocation. If you are not executing, no allocation, and when you're allocating also, we allocate how much you require, that much only we are going to allocate. And that is the reason we call it as what? Dynamic language. Dynamically, it is going to decide how much memory is required for a program, that much memory is going to be allocated. We are not doing allocation at compilation time. That is a memory issue in C language, which you are resolved in Java language. We call Java as what? Dynamic language. Allocation of memory happens during the execution time, not during the compilation time. What is that word here? Guys, are you listening? What is this word here? Robust. Meaning, the meaning of robust is strong. We call the Java language a robust language, means Java is a strong language. Why do you call Java a strong language here? Java goes to gym every day. Java goes to gym every day. Then what? The word Java can be used in different angles here. Sorry, the word strong can be used in different angles here. I say one fellow is physically strong. Physically strong means what? More energy, more fit. Financially strong means what? More money, rich fellow. Mentally strong. They can make their own decisions. No one can influence them. Family background strong. Right? You can use the word strong or technically strong. More knowledge. So you can use this strong in different words. I say Indian team is strong. Then meaning what? Indian team is strong, meaning what, dear? There are some concepts in Java language. There are some concepts in Java language which are really excellent. Keeping those concepts in mind, people call Java language a strong language. Keeping that concepts in mind, people call Java language a strong language there. Let us see some names here. I read the name as, what is that word here? What is that word here? Memory management. Memory management. Now, when you say memory management, I supposed to discuss about two words. One is called as allocation, the other one is called deallocation. Allocation and deallocation. Now, what is this allocation? When you execute a program, your program requires some memory. Your program requires some memory, and your system is going to allocate some memory to your program. Am I clear here? To execute your program requires some memory. Your program requires some memory, and the system is going to provide some memory to your program there. The system is going to provide a memory to your program. That is called as allocation. Am I clear here? Once your allocation happens, you take the memory, you do the execution. After that particular execution is over, we need to give the memory back to the system. Am I clear here? Take the memory, use it, and give it back. Do allocation, do the execution. After the execution is over, give it back. Give it back. Am I clear here? Take the memory, do the execution, and give it back. Allocation and deallocation. So now, in language like C language, you are only responsible for both allocation and deallocation. You only should take memory, take it, use it. After using it, you have to give it back. Am I clear here? Now in Java, you don't have to do two things. You need to do only one thing, that is called allocation. Deallocation will be done automatically by garbage collector. So there will be your program will never contain your program will never contain what? Unused memory. Your program will never contain unused memory. It will be taken back by your garbage collector. It will be taken back by the garbage collector. Am I clear here? It is taken back by the garbage collector there. So there is no wastage of memory in that angle. And when you're doing allocation, we are just not discuss about saying what dynamic there. What is the dynamic? Allocation happens according to the requirement. So extra allocation will not happen there. So in Java language, allocation is also good. Deallocation is also good. Allocation time, there is no wastage of memory. After allocation is over, what? Deallocation also will happen immediately to avoid the wastage of memory. Am I clear here? This is what the best thing about Java language. No allocation during no wastage of memory during allocation time. And once the allocation is over, your program is not going to have any what? Your program is not going to have any unused memory. It will be taken back automatically there. So memory management in Java language is excellent. That is the reason people call Java a strong language there. Then I write one more word there. What is that word here? Exception handling there. Now, when you are writing a program, your program may contain some errors. Your program may contain some errors. Am I clear here? Now, that errors which occur in your program can be of two types. The errors that occur in your program can be of two types. Am I clear here? One, the errors which occur at compilation time because of the syntax. Every programming language will be what? Every programming language will have some syntax. And if you don't follow the syntax of that language, we are going to get some errors. That errors are called as syntactical errors. Am I clear here? Syntactical errors. That is one. By seeing the error, we can resolve them. But apart from that one, there is one more kind of errors which occur at execution time. And that errors will be because of wrong logic, wrong input to the program, wrong data in your program will give to that runtime errors, will lead to that runtime errors. And that runtime errors only are called as exceptions. An exception is a runtime error which occurs because of wrong logic, wrong input, wrong data to your program. Am I clear here? That is what the exception means. And whenever exception occurs in a program, whenever an exception occurs in your program there, whenever an exception occurs in your program, the execution of the program will be stopped. That is called as abnormal termination. Whenever an exception occurs in a program, the execution of the program will be stopped. The execution of the program will be stopped. The remaining program will not execute. Will not execute. Am I clear? Incomplete execution will happen. Abnormal termination will happen. Incomplete execution, abnormal termination will happen. Is the point clear here? And exception can occur in C language, C++, Java, anywhere. But when an exception occurs in a program, it is going to do, it is what? Abnormal termination, incomplete execution. Abnormal termination, incomplete execution there. Now to avoid that one, in C language, there is no concept. Am I clear here? In C language, there is no concept of what here? Exception handling. Once the exception occurs, the story of the program is over. The story of exception is over. Sorry, the story of the program is over. No more execution. But in language like C++, Java, we have exception handling. But the problem is what in C++, you have exception handling concept. You do have exception handling concept, but what dear, you have to write huge amount of code to do the exception handling. You have to write huge amount of code to write the exception handling. Is the point clear here? But in Java language, the exception handling is very simple. You just have to write few keywords and your exception handling is done. And with that, you can what? Execute the remaining program and do normal execution. Complete execution can be done. You can execute the program completely and terminate normally. Is the point clear here? That is what you should do there. So, Clavis, there are many concepts in Java language which make them strong. So, keeping all these things only, people call Java language is what? Strong language, or you can call it as what? A robust language there. A simple word there. Then there are two more words which are something appears to be similar, but both are in different lines here. One is called distributed, and let me put one more word that is called as multi-threaded. The purpose of both of them is to improve the performance only, but there is a difference. What do you mean by distributed? Java is a distributed language, meaning using Java language, we can develop distributed applications. Am I clear here? Using Java language, we can develop distributed applications. What is the meaning of this distributed applications, dear? It has to have some meaning, like distributed applications there. The meaning. Now, you all access Google, right? Now, when you access this Google and all, is a Google application present in your machine? No. The Google application is present in some other machine. Then what do you do here? In our system, we open a browser. Am I clear here? We open a browser, we type www.some site, google.co.in. The request will go to server. The server will get back the website. Then, next what you do is, you type some content and click the enter button there. The request will go to the server again. It will fetch your data and search for some data and give you. Am I clear here? That is what going to happen there. So whenever you want you're searching something, you send one request. Request will go all the way to the server, and it will search for your data. Response will be sent back to your machine. Your machine is the client machine, and where the data is coming from is called the server machine. Client server, two machines are available. Now, are we the only one fellow who search for data in Google and all? No, there are many people in the world who search for data in Google. In every second, Google server receives some millions of requests. Every second. Entire world is searching for data in Google there. So every second, the Google fellow is going to receive some millions and millions of requests. If so many requests are there, then when I send a request, the Google server tells hey Praveen, there are a lot of requests pending here. I cannot send the response now. Please wait for 24 hours. Tomorrow morning, I'll send the response. Can you wait for a response to receive from the Google for 24 hours? No. 24 minutes? Impossible. 24 seconds. This also is very difficult because when you're searching for some data, we type something and we hit the button. By the time we release the finger from the button, we want the response back. Means it is fraction of seconds. In milliseconds, you want the response. In milliseconds, we want the response, dear. So fast. But if there is only one server across the world, all the requests have to go to the same server, then 100% there will be a delay in the response. There will be a delay in the response. To avoid the delay, what will Google Fair do is they'll place one server in India, one in Bangladesh, one in China, one in Sri Lanka, one in that country, one in this country. Everywhere they are going to place some what? They are going to place some servers. So when I send a request, the request will always go to the nearest server and fetch the data. The request will always go to the nearest what? Server and fetch the data. So what happened now? The load on the server is reduced. The load on the server is reduced and the performance is improved. Am I clear here? The load on the server is reduced. The load on the server is reduced, performance will improve. That is what going to happen there. Is that point clear here? Distributed. So Google is a distributed application. So like that, we can develop what? Distributed applications using Java language. Now, what is the second word I wrote there? Multi-threaded. Multi-threaded. What is this multi-threaded? If a language is supporting multi-threading, am I clear here? If a language is supporting multi-threading, if a language is supporting multi-threading, then we call that particular language as multi-threaded language. What is this multi-threading, dear? Multi-threading, if a program contains multiple threads. If a program contains multiple threads, then we call it as multi-threading. Multi-threading. What is a thread there? Dear, thread is nothing but a thread is a control in your program. A thread is a control present in your program. If your program contains multiple controls, am I clear here? If a program contains multiple controls, if a program contains multiple controls, then we call it as multi-threading. Why, Praveen, multiple controls are required in your program? Dear, it's something like today, after this class, I go to one mobile store. I want to buy something. So when I walk into the store, am I a customer or not? I'm a customer. The shop fellow is talking to me. I'm a customer, the shop fellow is talking to me. When the shop fellow is talking to me, another customer comes. Another customer comes. What will the shop fellow do? The shop fellow will tell what? Second customer, get out. Please come tomorrow. I am talking to another customer here. Will they tell you that? No. Then what? Then what? The shop fellow will tell the second fellow, please wait, sir. Sit here. I am talking to another customer. I'll talk to you in 2 minutes. Please sit here. Am I clear here? That is what the shop fellow will tell. Third customer comes, same thing. Fourth customer comes, same thing. 10th customer, same thing. Assume you're a 10th customer. You're a 10th customer. And what happens? The shop fellow will tell you the same thing. Sir, please wait. I am talking to another customer. But your 10th fellow, your number comes out to 9 fellows. Am I clear here? If the shop fellow is talking to every customer for 5 minutes also, by the time the control comes to 10th customer, the 10th customer has to wait for what? Almost 50 minutes, 1 hour. Am I clear here? They have to wait for so much time. Is the point clear here? You have to wait for a lot of time. You have to wait for a lot of time. This is what? Waiting time is huge. So as a customer, 10th customer, can you tell me, will you wait for so much time? Will you wait for so much time? Am I clear here? No. Then what will you just? You walk out and go to another store. Then the shop fellow will lose business, and no shop fellow want to lose business. So what they do? We cannot wait for so much time. So how Praveen then the shop fellow will increase the sales people? The shop fellow will have 10 sales fellows. The shop fellow will have 10 sales fellows. The moment first customer walks into the store, first sales fellow will talk. Second customer comes, second sales fellow will talk. 10th customer comes, 10th sales fellow will talk. So what happens now? The amount of waiting time is reduced. The amount of waiting time is reduced. Performance will improve. Am I clear here? That is multi-threading. And using Java, we can create multi-threaded applications. This is going to improve the performance by reducing the load on the server. This is going to improve the performance by reducing the waiting time. But both are going to improve the performance of the application there. These are different words that people talk about as features of Java language. And Nikita, this what you are using here, high performance here. Execution of your program is done by whom? Jvm. And inside the Jvm, who is there? Interpreter. Interpreter is slow. So we don't want execution to be slow. So what they've done, along with the interpreter, they have added an extra compiler called JIT compiler. So inside your JVM now you have two fellows. One is the interpreter, two is JIT compiler. If both are doing the execution parallelly, automatically execution time will be reduced, performance will improve. And that is what we call high performance language. How it will happen, I'm going to talk in the next session. And the next session we're going to talk as, what is that word? Can you see? Jvm architecture. This is our first topic there, Jvm architecture. So what is the input to the JVM? Dot class file. It will take the dot class file and give machine language instructions. Now, what are the different things available inside your JVM? What they perform? All those things we are going to learn under this particular concept called Jvm Architecture. Why these two fellows are there? How they will work together? How they improve the performance? This all we are going to talk in Jvm Architecture. Is it okay, Nikita? So try to recollect these words. We'll talk about this Jvm architecture in the next session on Monday. You have any queries, dear? So we'll continue on Monday, dear. Thank you, guys. Slowly we'll get Naresh all those things. See you on Monday, dear. Thank you.